So the first thing you want to do is look at your directions. It asks you to factor out your greatest common factor, GCF. And when that is the case for the directions, the format is going to be GCF is on the outside, what's left over is on the inside. So make sure you're aware of that. Okay, so the first thing we can do is determine, let's see, out of the three terms, what is the greatest common factor in terms of numbers? So I can do several methods to determine that, but for the sake of time, I know it's going to be a -5. So as a side note, I need you to understand if you ever have a leading coefficient that has a negative in front of it, you automatically have to bring that negative out with your greatest common factor. If I look at all three terms, I will notice that they do not all have an X. If I look at all three terms, I will notice that they do not all have a Y. So in this answer, I will only have a -5 as my actual GCF. What's left over comes from me simplifying. -35 divided by -5 is a +7, and then I will bring down the X. 20 divided by -5 is -4, and bring down the XY. -50 divided by -5 is a +10, bring down the Y. This is my final answer. It's in the form of the greatest common factor on the outside times what's left over. However, I want to check my work, make sure that I'm on the right track. -5 times 7x is negative 35x. Don't know what happened there. Okay, -5 times -4 is +20, and then you have the xy. -5 times 10 is -50, and then you have the y. So if I end up right back where I started, that means that I have the correct answer. Moving on to the second one. Okay. Again, I have 4 different terms, and I'm looking only at the numbers for now just to see if I can quickly identify greatest common factor. In this instance, I'm going to use the prime factorization method. So for the first term, I have -72. And I wrote negative, but I'm only going to focus on the +72. I can come back and get that sign later. So 9 times 8, 9, factors of 9, 3 times 3, 4 times 2. And what you're trying to do is you want to just keep going until you end up with just prime numbers. So 3 times 3 is 9 times 2 times 2 times 2. If I multiply that out, I will end up at 72. So then I go to the next one, and since the second and the third term are the exact same, I'm only going to do the factoring tree one time. 8 times 8, 4 times 2, 4 times 2, 2 times 2 times, bring that 2 down, 2 times 2, bring that 2 down, and again, this is 2 times 2 times, that's what that means. So 2 times 2 times 2 times 2 times 2 times another 2 will result in -64, which is what we started with. 24, you can use 12 and 2, but I'm going to do 6 and 4. You can use any of the factors, and you just keep going until you get down to your prime numbers. So 3 times 2 times 2 times another 2 is 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So I know that I did my prime factorization correctly. So if I am looking at what they have in common, because again, we're looking for GCF, I notice that this one has 3 2's, this tree has 3 2's, and so does this one. Everything else is just something that's left over. This is what's left over that they do not have in common. So for the greatest common factor, for the numbers, I have 3 2's, which is 2 times 2 times 2, and that's 8. I go back to my leading coefficient and I see I have a negative. So that means that negative sign has to come out as well. So now I'm going to look at my variables. This one does not have an X, so I don't even have to bother bringing out an X. If I look at the y's, I am looking for the one with the smallest exponent. So y to the fourth is my greatest common factor between all of the variables y. This is my actual greatest common factor for the entire expression. So remember that format I told you. The greatest common factor goes on the outside. What's left over goes on the inside. So what's left over, you can do it two ways. What I circled in the factoring tree, that's what's left over. 3 times 3 is 9. Or you can take this information that's on the outside, the greatest common factor, and you can divide each term by that. So we already did the first one, so we'll just go over here since I didn't leave any space there. Actually, I'm going to erase that and bring this down. So negative, oops. So you can see what's happening. All right, here again, negative 8 y to the fourth. And once I divided negative 72 by negative 8, I end up with a positive 9, which is the exact same thing that I got from my factoring tree. And now if I'm looking at my variables, y to the 6th power divided by y to the 4th power is simply subtracting your exponent. 6 minus 4, that's how many y's? Y to the 2nd power. If I go to the next one, again, I can look at my factoring tree if I wanted. 2 times 2 times 2 leaves me 8. So I have a positive 8, or I can look at my terms. Negative 64 divided by negative 8 is positive 8. Y to the 5th divided by y to the 4th is simply 5 minus 4. That leaves me with a y. And just for the sake of being consistent, again, all 4 terms have to be divided by your greatest common factor. We know it's still going to be 8 because it's still that negative 64. So positive 8. And y to the 4th divided by itself, there's no y left because it's simply, if you're dividing it, it's just 1. But if you're doing the exponents, it's 4 minus 4, which is 0. So there will be 0 y's. And then finally, if we go to the next term, the last one, we can look at the factoring tree and see, I'm sorry, I forgot to bring my x down. I didn't see that. So there's the x right there. So look at the factor tree, and it's going to be a 3. However, make sure you pay attention to the signs, because when I was factoring, I didn't keep up with my signs. I knew I was going to go back and do that later. So negative 3, and then y to the 4th divided by y to the 4th simply goes away. So this is your final answer. And again, we want to double check. Negative 8 times 9, negative 72. Y to the 4th times y squared is the same as adding the exponents 4 plus 2, which is y to the 6th. Negative 8 times 8 is negative 64. Y to the 4th times y to the 1st. Remember, there's a 1 there. It's understood. 4 plus 1 is 5. And why you guys didn't tell me I forgot my x? There's an x there. Okay, and then let's see here. Let's go back and do that. This is why you want to verify your answer. So again, negative 64, y to the 5th, and there's my x. Okay, now here, negative 8 times, let's go back to my green. Negative 8 times 8 is negative 64. Y to the 4th is accounted for, and then the x is accounted for. Negative 8 negative 8 times negative 3 is a positive 24, and then the y to the 4th is accounted for. So again, if I double check my work, which as you can see is when it gets messy up in here, you might miss something. So always double check your work to verify that you have accounted for all of your terms. So now I know that I can move on. Let's go to the next one. All right, here. Yeah, let me use a different color. So I'm looking at this and I can clearly see that the smallest number can be, all of these numbers can be divided by this smallest number, 6. So I know 6 is going to go outside. I do not have a negative sign in front of it, so I don't have to put 1 on the outside, even though you see a negative sign there. So don't get confused by that. Now I look at my x's. I have x's in every term. So, and the smallest number exponent is 2. So I'm going to write x squared. And then for y, The smallest number is 3, so y to the third power. Now from this point, I am dividing each term by that greatest common factor. 6x squared, y cubed, 6x squared, y cubed, 6x squared, y cubed. I try to line them up so it's a little bit easier to keep track of it. Okay, I'm going to move this down. That's too crowded. And I'm going to change colors. All right, so 6x squared, y cubed. What's left over? I can get rid of that. I can get rid of that. And I'm left with y to the fifth divided by y cubed, which is y squared. Again, 5 minus 3. Negative 12 divided by 6, negative 2. X cubed divided by x squared. I'm subtracting 3 and 2, so I end up with just 1x. Y to the fourth divided by y cubed, and I'm subtracting 4 minus 3. I end up with 1y. Now, 36 divided by 6 is a positive 6. X squared divided by itself, I do nothing with that. Y to the fourth divided by y cubed, 4 minus 3, which is just 1. And then negative 60 divided by 6, negative 10. X squared divided by itself, y cubed divided by itself. I am finished. Double checking my work. Let's find a different color. All right, 6 times, there's a 1 right there, it's understood, it's 6. X squared is accounted for. Y cubed times y squared is the same as 3 plus 2, which is 5. 6 times negative 2 is negative 12. X squared times x to the first is 2 plus 1, which is 3. Y cubed times y to the first is 3 plus 1, which is 4. 6 times 6 is 36. X squared is accounted for. Y cubed times y to the first is 3 plus 1, which is y to the fourth. 6 times negative 10, negative 60. X squared, y cubed. Awesome sauce. How are you guys doing? Okay. Now we look at the directions. This time it says factor each completely, which tells me I am now going to have, most cases, a binomial answer. So I'm not being asked to factor out the greatest common factor this time. I'm asked to factor completely. So this is when you would want to use the box method. There are other methods, but this is what I taught you in my class. So you have 1, 2, 3, 4 terms, and you have 1, 2, 3, 4 cells in the box. So just take each one in the order that they are shown and place them in the box along with the sign that is attached to it. And then positive 16. So this is now you want to go back to factoring out your greatest common factor. And let's go to the left first. If I look at 21a cubed and negative 14a squared, and I ask myself, what do they have in common, the greatest common factor, I will recognize that it's 7. If I'm looking at the exponents for my variables, the smallest exponent is 2, so my a value will be 2. Now, if I go to my next row, I look at the numbers 24 and 16, and I recognize out of the 2, there's an 8. That's the largest number. However, I see the sign negative in this cell, which means it's going to be a negative 8. This one has a variable, but the fourth cell does not have a variable, so there will not be a variable that comes out. The way this works is the cell that is closest to where you're writing is the sign that you're going to take. So this is a positive 21, so your answer will be positive. This is a negative 24, so your answer will be negative. Going in the opposite direction vertically, for those people who can't see, you can't see it, you might want to write it horizontally. So I'm taking the first cell and the cell that's under it. So 21a cubed minus 24a. And then the second cell and the cell that's under it, negative 14a squared plus 16. So maybe you can see it better now and ask yourself, well, what do they have in common? What's the greatest common factor? So between 21 and 24 is going to be 3. And again, if you wanted to, you can do your factorization, your prime factorization, the factor trees. And then if I'm looking at a cubed and a, the smaller exponent is 1. So I'm going to take out 1a. Looking at the cell below this, I notice the sign is a positive, so my 3 will be positive. If I look at the next one, I notice the sign is a negative. That's closest, this box or cell that's closest to where I'm about to write, so I'm going to write a negative. And then I ask myself, what is the greatest common factor between 14 and 16? And I recognize that it's going to be 2. And again, these are my factors, but I am not finished. So these are my factors. I'm not finished because I don't have it in the proper form. I have to put it in the correct form. So I am going to, which is this, take the one to the side. It doesn't matter which comes first. I'm just going to choose this one. 7a squared minus 8 times, and then the one that's on top, 3a minus 2. And I am going to double check my work. 7a squared times 3a is 21a cubed, so I can either locate it in the cell or where I started. 7a squared times negative 2 is negative 14a squared. Again, it's in the second cell or it's the original problem. I don't have to do both. I'm just letting you know it's there. Don't forget the sign when you're multiplying. So negative 8 times 3a is negative 24a. And finally, negative 8 times negative 2 is positive 16. Woohoo! We're on the roll. Okay, and the last one. Again, we are factoring completely. So some of you, I noticed that you want to do the factoring by grouping. You can do that if you want to. I'm not teaching it. I'm teaching the area model, but I just kind of let you know when you can do it. If you can draw a line just like I just did, and if you can take that first term and divide it by the second term, 28 divided by 4, you will get a 7. If you can do the exact same thing on the second side and get the exact same number, you can factor by grouping. There are times you will not be able to factor by grouping. This is how you can tell if you can. So again, for the sake of being consistent, I am just going to stick with the area model, which is the box method. But you can do the factoring by grouping. I won't hold that against you unless the directions specifically say you have to use the box method. So again, I'm going to fill in my boxes based off of the problem. So my first term, second term, third term, and fourth term. I am going to take my greatest common factor between the two rows. And if I am looking at the first one, 4 is divided by 4, and 28 can also be divided by 4. So we know that 4 is the greatest common factor between the both of those. And if I'm looking at my exponent, 2 is the smaller of the two, so that's what I'm going to go with. And if I'm looking at the sign, this is a positive 28, so this will be a positive 4. If I look at the next one, the sign for the cell that's closest to where I'm about to write is positive, so I know it's going to be a plus. 7 and 1 can both be divided by 1. So make sure you put something here. You can't just leave it blank. You have to have a number here because there's not a variable in this case. If there was a variable, you would put a variable. All right, so now we're going to go up to the next one. And we're doing the greatest common factor that way. For those people who cannot see it vertically, write it horizontally. You're going to take the first box and the box that's under it. You're going to take the second box and the box that's under it. And now you should be able to see what is the greatest common factor between those two. 7 and. Why is it a positive 7? Because there is a positive 28. So the sign of the box that's nearest where you're writing is the sign that you're taking. If you go to the next one, 4 and 1 can both be divided by 1, and the sign in front of 4 is a positive sign, so it's going to be a positive 1. So again, this sign, If there's not a sign in front of it, it's understood to be a positive. That's what goes outside. That's the sign that goes. Okay? Let's use a different color here. These are my factors. I cannot leave it like this. I have to complete the problem. So if I am completing the problem, I put it in factor form. It does not matter if I choose the top factor versus the side factor. Doesn't matter which order. Signs matter. All right, now if I double check my work, I have 7n times 4n squared, which is 28n cubed, can be located there or in the box. 7n times 1 is itself, which is 7n, and that's right here. 1 times 4n squared is itself, 4n squared, there, and it's also there. And then 1 times 1 is itself, which is positive 1. How'd you guys do? Okay, it's time to take your quiz now. So go to E-Class, and when you are finished, please come back to this Nearpod so you can learn a few tricks. Your quiz is time.